Does the graph represent a linear or nonlinear function? Explain. Part A. A linear function is a function whose graph is a non-vertical line. A nonlinear function does not have a constant rate of change, so its graph is not a line. Here the graph is not a line, so the function is nonlinear. Part B. Here the graph is a line, so the function is linear. Does the table represent a linear or nonlinear function? Explain. Part A. As x increases by 2, y increases by 9, so the rate of change is constant. And because a linear function has a constant rate of change, the function is linear. Part B. As x increases by 2, y increases by different amounts. So the rate of change is not constant, and because a nonlinear function does not have a constant rate of change, the function is nonlinear. Which of the following equations represent linear functions? Explain. Y equals 2 to the xth power, y equals 5x, y equals 3 minus 2x squared, x minus y equals 12, y equals the square root of x plus 3. For an equation to represent a linear function, you must be able to rewrite the equation in the form y equals mx plus b. You cannot rewrite the equations y equals 2 to the xth power, y equals 3 minus 2x squared, and y equals the square root of x plus 3 in this form. So these equations represent nonlinear functions. The equation y equals 5x can be rewritten as y equals 5x plus 0. The equation is now in the form y equals mx plus b, where m is 5 and b is 0. The equation x minus y equals 12 can be rewritten as y equals 1x plus negative 12. The equation is now in the form y equals mx plus b, where m is 1 and b is negative 12. So the equations y equals 5x and x minus y equals 12 represent linear functions. Linear function y equals 1 and 25/100ths x represents the cost y in dollars of x bottles of orange juice. Each customer can buy a maximum of 5 bottles. Part A. Find the domain of the function. Is the domain discrete or continuous? Explain. Note that you cannot buy part of a bottle. So because x represents the number of bottles of orange juice,
It must be a whole number. Note that each customer can buy a maximum of 5 bottles, so the domain of the function is 0, 1, 2, 3, 4, and 5. Because the domain consists of only whole numbers, the domain is discrete. Part B. Graph the function using its domain. First, you want to make an input-output table. The input values are 0, 1, 2, 3, 4, and 5. 1 and 25 hundredths times 0 equals 0. 1 and 25 hundredths times 1 equals 1 and 25 hundredths. 1 and 25 hundredths times 2 equals 2 and 50 hundredths. 1 and 25 hundredths times 3 equals 3 and 75 hundredths. 1 and 25 hundredths times 4 equals 5 and 0 hundredths. 1 and 25 hundredths times 5 equals 6 and 25 hundredths. So to graph the function, you want to plot the ordered pairs 0, 0, 1, 1 and 25 hundredths, 2, 2 and 50 hundredths, 3, 3 and 75 hundredths, 4, 5 and 0 hundredths, and 5, 6 and 25 hundredths.
The runner's speed is 5 miles per hour. The number m of miles run is a function of the number h of hours spent running. Part A. Does this situation represent a linear function? Explain. Because the runner's speed is 5 miles per hour, as h increases by 1, m increases by 5. So the runner is traveling at a constant rate, which means the rate of change is constant. So yes, the situation represents a linear function. Part B. Find the domain of the function. Is the domain discrete or continuous? Explain. Because h is the independent variable, the domain is the set of all possible values of h. Because the number of hours spent running cannot be negative, the minimum value of h is 0. You can run for part of an hour, so the domain is h greater than or equal to 0, and the domain is continuous. Part C. Graph the function using its domain. To do this, you first want to make an input-output table. Use input values in the domain, such as 0, 1, 2, 3, and 4. After 0 hours, the runner has traveled 0 miles. So when h equals 0, m equals 0. Each hour, the number of miles run increases by 5. So after 1 hour, the number of miles run is 5 more, or 5 miles. So when h equals 1, m equals 5. Similarly, when h equals 2, m equals 10. When h equals 3, m equals 15. And when h equals 4, m equals 20. So to graph the function, you want to begin by plotting the points 0, 0, 1, 5, 2, 10, 3, 15, and 4, 20. Because the function has a continuous domain of h greater than or equal to 0, draw a line through the points starting at 0, 0. Write a real-life problem to fit the data shown in each graph. Is the domain of each function discrete or continuous? Explain. Part A. You want to think of a real-life situation in which there are two variables, x and y. It may help to display the data in a table. Using the graph or table, you notice that as x increases by 1, the value of y increases by 10. The x values are 0, 1, 2, 3, and 4. The y values are 0, 10, 20, 30, and 40. Using this information, one possibility is the books on a website each cost $10. You can buy a maximum of 4 books. Because it is not possible to buy part of a book, the domain is discrete. Part B. You want to think of a real-life situation in which there are two variables, x and y. Using the graph, notice that as x increases by 1, the value of y increases by 1/2. The x values can be any real number greater than or equal to 0, and the y values can be any real number greater than or equal to 0. Using this information, one possibility is the frozen yogurt at one store costs 50 cents for each ounce. Because it is possible to buy any portion of yogurt, the domain is continuous. Yogurt